Yeah, so hi guys. In this video, we will be having a look at one more sorting algorithm, which is quick sort. This is our fourth sorting algorithm, the quick sort. Okay, so very quickly we will understand how we are going to approach this sorting. So I will write the pseudo code for the quick sort algorithm. So QS, we will get an array, low and an R, right? We will check if L is less than R, then only we will make a index pi, the partition in which we will call this helper function with parameters array and length. Right, now we will recursively make a call to this function for ARR from L to pi minus 1. Similarly, quicksort ARR pi plus 1 and R. And after this code, our array will be sorted. This is the high level uh, pseudocode for this sorting algorithm, the quick sort. Right, this function, the partition we need to write. So first of all, I will give you idea how this function will work. Right, suppose we have this array 4, 8, 7, 1 and minus 2. Right, so in quick sort we have to choose an element as pivot. So we generally choose the first element as pivot, and uh, we will uh, suppose here we will choose this element as pivot, and we have to move this elements to its right place, right? Such that all the elements which are left to this elements are smaller, and all the elements which are greater at the right side, uh, keeping the relative order of elements like this. We will have this 4 here, and 1 and minus 2, and here we will have 8, 7. Right, so this function will do this job. He will choose the first element as pivot, and the pivot element will move to its original place. This is the right position of 4 after sorting. And the all the elements which are smaller in left, and all the elements which are greater to right. Now similarly, we will make a call for these arrays. Uh, the our array will be this only, but now our 4 is at its place. So we will make a recursive call for load to pi minus 1. Pi is this, so this array we will make for this here, and here we will make a call for this array. So from these two elements we will choose a pivot, which is the first element, and we will move this element at its right position. Its right position is -2 and 1 and 4 and 8 7, right? So now this array is also sorted. Now we hit the base condition, so this call will not go uh, after this. Similarly, we will execute for this. We will choose the first element as pivot, and we will move this element at its right place on uh, sorry. At this point, this these two elements are will be there at their place, right? So 4 7 and 8. After this call, you can see our array is sorted now. So how we are approaching this problem? We are given an array. We are getting this partition index, and then after that we are making a left call from low to pi minus 1 and a high call to pi plus 1 to r, this and this. Likewise, our array will become sorted. Here you can see if we have chosen this element, it will make a call for our L was here, our R was here. Now, if we divide, our L and R will become both this, and this will be separate array L and R. So here it will end. The recursion will not go forward from here, right? So if I write the code for this function, the partition function, right? If I write the code for the partition function, it will look like this. It will return an int. We are uh, taking the int value and storing in pi. So int partition, it will take an array L and R, right? First of all, we will choose a pivot, which we discussed would be the first element. After that, we will have a pointer I, L, and J, R. Now, while I is less than R, I is less than J, what we will do, we will say while another loop, while I is less than equals to R, and ARR of I is less than equals to pivot, we will say I plus plus. Similarly, we will have another loop while j is greater than equals to L, and ARR of j is greater than pivot, then we will say j minus minus. After this point, we will swap. We will check if I is less than j and swap ARR of I and j. After this while loop, just one last thing that we need to do is we need to swap ARR of L low with ARR of J, right? So how we are doing this, and we can return j. This is the pseudo code for the partition function. Partition function. So what we are doing here, we are this is our pivot element, right? So we are moving the I pointer until we see if the element is smaller than pivot. So if the element is smaller than pivot, then it should stay at the left side only. As soon as we find an element greater, we will stop. So the I pointer will stop here because this element is greater than the pivot element. Pivot. Similarly, we are decrementing j until we find if the element is greater than j, right? So we are finding a smaller element here. While j is greater than L and ARR of j is greater than the pivot. So if the element is greater than pivot, so it should stay at the right side. So we are decrementing the j, but this element is already smaller than the pivot, so j will not move. And after this, we are swapping I and j. So the array will become 4, -2, 7, 1, and 8. Right? Our j is here and our I is here. Right? Our j and I is here. Now again we will run into this loop. We will check uh, this element is smaller than the pivot, so we will increment I. This is greater, so we will stop. This is greater, so we will decrement j. This is smaller, so we will stop here. Then we will swap those ij. 4, -2, 1, and 7 and 8. Right? J is here and I is here. Now this element is smaller than pivot, so we will increment I will be here, right? Now this element is greater than pivot, so we will stop the I loop. Now we will run the j loop. We will check this element is greater than pivot, so we will move j here. This element is smaller, so we will stop. So this condition will become false, so we will not swap because now I is not less than j. I is greater than j, right? Now what we'll do, we will swap the pivot with the jth element. So after this, the pivot element will move to its right position. So 1, -2, and 4, and 7, and 8, right? Now you can see after this function call, the pivot element is at its right place and all the elements to its left are smaller than pivot. All the elements to the right are greater than pivot. Right now, when we will get this index, j index of this element, which is the 2, then we will make a recursive call for this part and we will make a recursive call for this part. Again, for this part, we will find the index, pi index, and make the other two recursion calls. Likewise, we will do for the right. When the left is resolved, we will do for the right, and by doing that, our array will be sorted. I hope it's clear how this quicksort algorithm works, so I have written the code here. So this is the main function, the quicksort function. We are checking if L is smaller than R, then we are executing this code. We are getting the index after sorting the index of the pivot element, and we were making these two calls for the leftover arrays. The left uh, leftover array, left part of the pivot and the right part of the pivot. And here in this partition function, we are doing what we just discussed. We are taking the first element of the array as pivot, initializing I and j, and running this loop. So after this I pointer, the I is at element which is greater than pivot, which is greater than pivot. And similarly the j will be, j is at element which is smaller than pivot, right? So after that, if the I is less than j, we will swap those two values. And after swapping, here what we are doing, we are swapping ARR of L and j, right? Because the pivot will go to, the pivot element will go to its right place, and we are returning the index of the pivot element. Yep. So if I'm running this code for the same array, yeah, we see the array is sorted. Yeah. That's it for this video, guys. Thank you for watching.